This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Digitalocean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
This is Nate Black for Software Engineering Radio. My guest today is Gary Rennie. Gary is a core contributor to the Phoenix framework and is a core member of the Plug team. He has given talks at several Elixir conferences, including at ElixirConf EU 2016, a talk called The Road to 2 Million WebSocket Connections. He currently works for VoiceLayer, a push-to-talk voice communication platform. Gary, welcome to Software Engineering Radio.
Hi, thanks for having me on the show.
In episode 336, Sasha Urich on Elixir, we covered the Elixir programming language. In that episode, we briefly discussed the Phoenix framework, which is written in Elixir, and today we'll discuss the Phoenix framework in more detail. Gary, what is the Phoenix framework?
So if you look on the website, I think it's described as a modern web framework and as a focus on real-time and maintainability, and I guess productivity as well. So you can build your application and get up and running quickly, but also as you get down the line into production, you can maintain it easily as well.
There are a lot of web frameworks out there, so what is it that differentiates the Phoenix framework?
First off, it runs on the Erlang VM, which means you get a lot of the fault tolerance that comes with that, and the error isolation as well. And then from a Phoenix perspective, the focus on real-time is definitely something that is more unique to Phoenix that you may not see in other web frameworks. And that allows you to have like a real-time web application that updates dynamically as things happen. Like, for example, if a new event comes in, you can send that straight down to the user and their UI will update appropriately.
When you say real-time, what are you talking about? Do you mean WebSockets?
So Phoenix is transport agnostic, and out of the box you get WebSockets and long polling, but there is like a behavior in Elixir that you can define that allows you to create your own transport if you have a different protocol that you may want to use for an embedded device or a native application or something.
Okay, so not necessarily WebSockets, but that is one thing that comes out of the box.
I would say WebSockets are probably what most people will start with at least, and then you may find use cases where the other things are appropriate. But if you got an old browser, like maybe you need to support IE7 for some reason, then you can use the long polling and it'll fall back for you.
What is adoption like? How many people are using Phoenix, and what are they using it for?
So I can't give you concrete numbers. I know that at ElixirConf, the attendance is generally up year on year, and most of the time, Chris McCord, the creator of Phoenix, asks how many people have Phoenix in production, and the number of hands that shoot up definitely increases as the years go on. In terms of big companies using it, I know Bleacher Report are a big user of Phoenix. I know Pinterest have Elixir in production. I'm not sure if they're using Phoenix or not. There's also Toyota Connected, who are doing things with real-time vehicle tracking, and they're using Phoenix. And then I think also Square Enix, I've met some people at conference there, and they mentioned Phoenix. So I think they're using it as well.
Okay, so it sounds like it spans everything from consumer mobile applications to automotive to gaming even. Is there an organization backing Phoenix, or who is backing Phoenix?
So Phoenix is an open source project, so a lot of the core team put their own time into it. Chris McCord, who's the creator of Phoenix, started it on his own in his spare time, but has since been employed by Dockyard, who are an agency, and they allow him to work on it for the majority of his time. I think he does some client work as well, but the majority of his time is spent working on Phoenix. And then from the Elixir side, Jose Valim and his company Plataformatech, they also sponsor him to work on Elixir. He's also part of the Phoenix core team and the Plug core team, so he also spends time on those.
You already mentioned that Phoenix has real-time communication out of the box. What are the other features that it has out of the box?
So when you get started, you'll install what is known in Elixir as an archive file, and that's a dependency that'll sit in your system, which will allow you to run tasks like against your file system. So you can run the Mix Phoenix New task, and that will be the like project that it generates for you. And then when you do that, you have a few options. Like you can have an API specific version that won't have any of the HTML rendering parts. But if you don't set that flag, then you'll have Ecto in there, which is a database library we can talk about. You'll have Phoenix core library, which has all the functions for controllers and views and templating. You'll have channels, which are the real-time abstraction. There's a routing layer to route paths to function calls. We have some asset compilation, but we haven't written our own asset compilation pipeline or anything. We delegate to Node.js and use one of the Node dependencies. So prior to 1.4, we've been using Brunch, but as of the 1.4 release, which isn't released yet, we'll be switching to Webpack.
And is there some kind of unifying paradigm that describes Phoenix as a framework? For example, I know that some web frameworks use the MVC model view controller paradigm. Does Phoenix use MVC or something else?
Kind of. So it's described as an MVC framework, and it certainly has views and controllers. In terms of models, we have this concept of contexts, and a context is a group of related functions that contain your business logic, and they may involve some sort of persistence layer, which could often be your database, like using Ecto. But you can also use Erlang built-in, or like Erlang has a built-in database called Amnesia. You maybe aren't using a database at all. Maybe it's using like Ets Tables, which is Erlang term storage. But whatever your case for your business logic, it goes in these contexts. So, for example, if you had like account creation and user registration, then you may have an accounts context, which has functions like register user, lookup user, and that's where all that code would live.
It sounds like the context is basically a way of organizing your code into related bits of functionality. In the Elixir episode 336, we talked about Elixir having modules and functions. So functions being grouped into modules. So how are contexts different from a module?
They're not actually. That's the beauty of them, is that it's just a module that contains functions. The context is purely a naming construct from the Phoenix side, and that just lets you have something that you can reference. Like it's hard if you just call it a thing, so it's got a name. We'd settled on context for it. I think the name comes from domain-driven design, but it's not like a pure implementation of design. Domain-driven design. It's just taking some of the concepts.
Why did Phoenix decide to introduce this context thing? What does the context do?
One of the problems we were having in Phoenix before context was the controllers were having quite a lot of business logic in them, and they were growing large and a little bit more difficult to maintain. And that was because there was no defined place to put this functionality. So they were using something context-like without any formal naming, but there was nothing Phoenix specific. So we introduced this context terminology as a place to put your functions or grouping of functions. And the benefit here is that it keeps your controllers thin, which is one small benefit. But you also then can call all the functions that affect your business domain outside of a controller. So Elixir allows you to run an interactive terminal using IEX. So if you have the accounts context and register user, then there's no dependency on any of the connection information. So you can just go straight into your interactive terminal and type accounts.register user, and then just type the parameters in there like name, Gary, whatever, and that will create a user from the terminal. or from the interactive console. You may also allow user registration over WebSockets, for example, and in which case you would just call the accounts register user function from your socket. So it allows you to build different interfaces into your application where the web part of it is only one interface.
What is the layout or structure of a Phoenix program? How does it look within my IDE? What would I see laid out on the file system?
So you'll generate your project using the archive I mentioned earlier. And when you do that, if you don't provide any flags, then you'll have a lib directory, which is where all your code will sit. You will have, from in there, you'll have two different directories. So you'll have one which is your web directory, where all your controllers and your views and templates will go. And then the other will just be, it's named whatever your application's called. And inside there will be all your business logic, which I guess is your model. And you would then have a testing directory where all your tests go. There's a mix.exs file, which is how Elixir projects define things like their version, their name, maybe their dependencies as well. And by default with Phoenix, your dependencies will be the Phoenix package on Hex, which is the Phoenix library code as opposed to the Phoenix generator code. You'll have Phoenix PubSub, which is the PubSub layer that powers a lot of the real-time system. You will have Ecto, and Phoenix Ecto, which is a bridge between Ecto and Phoenix. And you'll have Phoenix HTML, which defines all the functions for HTML helpers like form4 and content tag. And you will also have live reload in development. So Phoenix is generally, when you're developing, live reloaded on the web page. So you make a change, you'll save it, and then the browser will update without having to refresh. And the last thing you'll have is an assets directory. And that's where we'll delegate to whatever your build tool is. There's a thin layer between them that you define in config, which says which command to run to build your static assets, which, like I say, by default will be Webpack or Brunch. And then they'll move them into the priv directory, which is a part of any Elixir release where your non-compiled dependencies go. So it could be like images or any fixture files you might have go in there.
The first step you mentioned was the archiver. So basically, this entire directory layout was created when you ran mix Phoenix new and was then put into this folder. And optionally, you had, if you had not specified to exclude like the database, you would have the Ecto folder. Is that right?
There's not an Ecto folder, but you bring in the Ecto dependency. And when you do that, you get access to some of the Ecto mix tasks. There's one to like create your database, one to run migrations, and the migrations live in the priv repo migrations directory. And you can also like tear down or migrate to a certain point, and that all comes from Ecto.
Okay, so Ecto, you mentioned earlier, was the thing that lets you interact with your database. So what is it? Is it an ORM, an object relational mapper, or what kind of technology is it?
So I guess because we don't have objects in Elixir, you couldn't classify it as an ORM, but you define schemas for Ecto, and you can define queries against those schemas. So you might say, this is a schema for the users table, and I have a name on there, and you define all this explicitly in a schema file per table. And then you'll say, like, my user's got a name, and they've got an age, and then when you interact with it, let's say you're querying and you want all users that are over a certain age, you would bring in Ecto. Ecto has like a query, ecto.query module, and from there you can call where or order or whatever it may be. So you could say order by age, where age is greater than whatever you're looking for. And from a data modification and insertion point of view, we have Ecto change sets, and a change set is self-descriptive. It's a set of changes that you want to apply. So the change set will run all your validations as well. So you put validations in your change set. So if you want to make sure that the user's age is over 18, you could have a clause in your change set that says the age must be greater than 18, and if not, you'll get a validation error.
Okay, so Ecto is not exactly an ORM, but it is some kind of abstraction layer. So then you're not writing SQL when you're interacting with the database, but you're using the Ecto API.
Yeah, so you'll define your queries and you build them up using transformations on a queryable struct, which could be if you define a schema, then you'll have like the struct will be user in this case, and that's queryable, and you can transform it using where and order and all the query API. And then at the end, you still haven't gone to the database yet. It's not until you call one of the functions in the repo module, so it uses the repository pattern. So you'll build up your query and you'll say like repo.all, and that's how you actually fetch all your users.
I'm not familiar with the repository pattern. What is that?
So it's where you have a module that has all your functions that actually interact with the database, and then you're building up all the transformations before that and then executing them against the database. You mentioned raw SQL as well, which you can actually use in Ecto with fragments. So once Ecto supports a lot of the functions you may want to use against your query, there are certain things that are missing, like maybe you're using the like JSON-B, for example, and there's maybe not a specific thing you need for searching on that. You can use a fragment and then a question mark, an interpolation character, and then you just pass the variables. And it also has two different query syntaxes as well. So it's got one that is function, well, they're both function based, but one is like you call the function and pass the list of arguments through. And the other is a bit more like, I think it was inspired by Microsoft Link, which is like the query language in C Sharp. So you can call things like from you in users, and it uses Elixir macros to write the query.
It's my impression that Ecto is something that you use to interact with relational databases. Is that right? Or does it allow you to also interact with NoSQL databases, or is there some other mechanism for interacting with those?
So you can define any data layer you want, really. And it's worth noting that you can have as many different repositories as you want. Like you configure each one individually. So there are other use cases for that. Like, for example, you may have a read replica, and you can use a separate repo for your read replica. And sometimes you'll query against that, and sometimes you'll query against your master. In terms of your data sources, it supports. There's a Postgres driver. There's a MySQL. MariaDB driver. There's a SQLite one, but there's also a MongoDB one. And I know someone wrote a GitHub API wrapper for Ecto, so it would query against the. So when you called repo.all, it would go and query GitHub, which is quite a novel use case, I thought.
It sounded interesting when you said that you could configure it to have multiple different repos, and you could have, for example, one as a read replica. Do you have an example of when you had that kind of configuration that you could use to illustrate how that works?
I know Bleacher Report did this because I think they did it to load balance some of their queries across different databases. I'm not entirely sure. We use it for that reason. So we use it sometimes if we have a read replica in a different region, for example. Then we're happy to have fast queries using the read replica, but more expensive writes that go to the master. So a lot of our writing logic will be configured for the main repo, and then a lot of our querying logic will use the read replica. And they just have different names as well. So instead of calling it repo.all, you'd call read repo.all.
Okay, so it's an explicit something explicit in your application. It's not just part of the configuration, but you'd be opting into this in a very explicit way.
Yeah, most things in Elixir and Phoenix tend to be explicit. So in this case, yeah, there's no magic way of saying these queries should go to this database and these should go to the other. It just depends on which repo you use at the point of executing your query. The other thing that is worth mentioning on Ecto as well is that it has something called multi. So everything's transactional from your query. If the transaction fails, then the query will fail, or the other way around. If the query fails, the transaction will fail. And Ecto also has this concept of a multi, where you can define a series of queries that all need to execute, like all need to succeed for the entire transaction to succeed. And that's transformational as well. So you could say ecto multi create user, and then ecto multi create default settings, for example. And if the settings fail to insert for whatever reason, then the user won't be created, it'll all be rolled back. And that's quite explicit as well. So you'll build up your multi, and then at the end you'll call repo.transaction the multi as an argument.
Okay, so it sounds like this is a way of creating transactions in the application layer versus just in one database. So you could have transactions that are spanning even multiple repositories and different, or multiple repos in different databases.
And also functions as well. So one use case we had recently is we wanted to create a user and then send them an SMS so they could, continue the registration. But if the SMS fails, then we don't want the user to be inserted so that it doesn't say like your phone number has been taken or anything. And in that case, if the SMS doesn't send, then we'll roll back the whole thing. So it doesn't just have to be database things. It can be any function.
We talked a lot already about the data part of Phoenix. What's we haven't talked about yet is the presentation or view part. What sort of template or view capabilities does Phoenix have?
The way Phoenix handles views is quite interesting. So there's a controller, which we can talk about in a minute, and they render into the view. And the view is a module, and in your view, you'll define functions, because that's how you do most things in Elixir. And your functions will be named render, and then you have the first argument will be like whatever you're rendering. So it could be render index, and then it has what we refer to as an assigns, which comes from plug, but it's essentially like a map of values. And when you render, you will pass these values to a template, which is an EEX template, and then the values will be interpolated and the HTML will be sent to the client. But what's interesting about the templates is they're actually at compile time compiled into functions on the module. So they're really quick because at runtime you're just calling a function and all the strings are already there in memory. And actually uses IO lists instead of strings, which is a more efficient data structure in Erlang if you're sending data like to a file or over a socket.
Could you talk about the different content types that Phoenix supports?
So plug, which is the library that Phoenix built on top of, allows you to parse the content type. And then from there, that's stored throughout the request. And then when you get to your view, which is usually one of the last things that will happen, you can have different, so as well as specifying the action that you're rendering, you can also specify the type. So you could have render index.html, and that will render your HTML, and that's fine. Or you can have render index.json, and if you return a map from there, then when that gets rendered, it will be encoded as JSON and sent back to the client. And usually this will be explicit, and you will, in your controller, say which one you want to render, but there is an option to have it look up based on the content type. If you pass an atom instead of a string, then it will try and work it out based on what plug saw earlier.
What does that mean practically? Does it mean that you could hit the same route, but depending on the content type, it would return JSON or HTML, or what would it mean?
That is what it means, and that's what it allows. In practice, I haven't really seen it used. I don't use it in any of my projects. I tend to be a bit more explicit, and if I have an API, it's on a separate path somewhere. But it is possible for, if you do have that use case, you can do it.
That's a good jumping off point for us to talk about controllers and talk a little bit more about plug. So you mentioned that plug was a key to all this, and that's something that the Phoenix framework built on. What is plug?
When you're using Phoenix, plug will be very visible to you. We don't try and hide behind it. If you're using plug, then it should be obvious to you because you'll often call plug dot something. And plug is two things. It's an abstraction around web servers. So typically you'll start your web server through plug. And it's also an abstraction around HTTP requests. So it'll handle anything that is related to an HTTP request, like parsing the headers or reading the headers, sending the headers, sessions, cookies, sending the response, status codes, anything like that. And it's typically what you'd use in Phoenix. Instead of having a special type of function for calling something before you get to your controller action, you would just call plug in there. So in your controller, you may see plug authenticate user, for example, and that will check if the session's set for that user. And if it is, then it'll continue. And if not, you can halt. So it's based upon pipelines, which are a series of transformations, and if any of them halt at any point, then the subsequent ones won't execute.
Yeah, so you said that it's an abstraction for web servers and HTTP requests. What is the abstraction? What is the common interface that defines the plug?
So the main thing that you'll be working with is the plug.con, which is a struct that has some 20, 25, 26 keys. And those are things like request headers, parameters, the response body, and you just transform these as you go, and they're all functions that take a con as an argument and return a con as the result. So you functionally transform the struct until it has everything it needs for the response, and then it'll send it. So you may have, like, let's say you've tried to fetch a user and it's failed. You can call plug.con.putStatus 404, and then send response, user not found. But you could do these two things in separate functions as well if you had some need to do so. So you can also have, like, for instrumentation purposes, you can have a plug there that records a time, and then you can register before send, which is like gets executed just before it's sent to the client. So you could start a timer in your plug function, and then just before it's sent to the client, you could just like record the value of the timer and then log it or whatever you want to do with it.
You mentioned before that you might have a plug function that's doing authentication, and then here you have some instrumentation. And so the request is going through this pipeline. Like first it's maybe starting the instrumentation, then it's checking authentication, then it's doing something else. So it seems to be just a list or a sequence of steps that the request is going through. Is that a fair summary?
Yeah, absolutely. So with Phoenix, we tend to say it's plugs all the way down. So the first part that you'll see in the entry point to your Phoenix application will be your endpoint, and from there you'll see a series of plugs. So the first one I think is like plug.static, and that's for handling static assets. So they get sent first because once you've sent a static asset, you don't need to do any of the rest of it. That'll just halt your pipeline there. And then there's things like plug ships with a few that are useful by default. So there's one that will like generate a request ID and store it on there. One that will log all your requests, either to the console or whatever logger you've got set up on Elixir. One that will force SSL. So maybe you don't want that in development, but you can conditionally set that in production. Phoenix adds some as well for like live reloading. It has a plug for that. So there's definitely a few. And then the last one you'll see is your plug.router. And that's a module that is also a plug that will have its own pipelines in there. So for example, for the HTML one, so for any HTML-based request, you'll have things like the prevent CSRF plug. You'll have one that like checks your cookies, maybe, and one that checks like the content type's valid. And you may have a different pipeline for your JSON that doesn't need to do those things. You just want to set the format as JSON. So that'd be a separate plug as well. And then at that point, after it's matched, the router gets compiled into a big function of pattern matches. And once that matches, you'll enter your controller, which is also a plug. And then that's where we started talking about it earlier.
Okay, so I was going to ask about how routing works, but you said that there's a router that is also a plug, it seems to be, and then that's the first thing that determines what controller that request goes through. Is that right?
Yeah, so there's a DSL that you use that you specify a scope, which is like a block of related functions. It's like a namespace almost. So you can have like a root scope, and you'll maybe have like an API scope. Within your scope, you can define which pipeline you're using. So I gave the example of HTML and JSON, but you may have one that's like authenticated requests or something else, and you can add those to the pipeline. And then you have macros in Elixir, like that we or Phoenix macros that are Elixir macros that are things like get and post and put and resources, which will generate like your CRUD actions. And you specify the path as a string, and then you specify the controller that should go to. And then when it gets executed as a plug, so it'll still have the con as the first argument and any settings as the second argument. and then that will call your controller action.
I'm sorry, I didn't quite understand what the second argument was. The first argument was the con, and what was the second argument to the plug?
So with plug, you can have the second argument can be anything, and there's typically options that are related to your plug. So, for example, you may have again, going back to the user authentication, you may have that, and then there's a setting you want to pass, like the name you want to use when you set that in the assigns, which I mentioned was the map of values that you can use throughout your request. So anything like if you look up anything and you want to store that for later use, so maybe like in all your user controllers, you look up the app that's being used first, and you want to store that on con.assigns, then you can look it up, then in con.assigns.app, you'd have the value that you looked up earlier. And then in your request, you can then look that up on con.assigns. You can either pattern match it, or you can just call con.assigns.app, and then you can use that throughout your request. And even down to your view, you can use it in your templates as well.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
You mentioned that the request starts at an endpoint and then goes into some pipeline, depending on how you configured it or how you wrote the code. Could you run through a concrete example so we can see how it works?
Yeah, sure. So the default endpoint will be named your application web. So let's say your application is called, I don't know, hello. It would be called hello web.endpoint. And in there, your request would come in, and the first plug it would hit would be the plug.static. And if you're requesting an image or a CSS file, that would resolve and return, and then the pipeline would be halted, and then that would be the end of your request. There's no need to go further. But assuming that's not the case, then it would probably start the logger, which would start timing the request, and then it would parse the request. So that means parsing the request body. So if it's JSON, it would JSON parse it based on the JSON coder you configure. That's another one of the dependencies that you'll find in your mix.exs, by the way, is like either Poison or I think we're moved to JSON now, which are JSON libraries. And then there will be the session plug, which will check anything that's stored in the session and make that available on plug.con. And then it will be your router, which you define, which will be called hello web.router by default. And in there, there'll be the pipelines I mentioned earlier. So there's a browser one that fetches the sessions and the flash messages, which are like one-time messages that exist on your next request. So in your controller, for example, if you create a user, you can set a flash to say created user, and then that'll be available for your next request, and then it'll go away, and you can show that message. And then things like the cross-site request forgery protection go in there. And then it would have the scopes, and then it would go to your controller. So by default, there's a page controller with an index action. And then inside your controller, you will have your actions are just functions based on the name. So in this case, you'll say when I go to the root path, call the page controller index function, and then index will be called with con as the first argument, which is the plug.construct, and params as the second argument, which is any parameters either from the query string or the request body that came in. And from there, you'll call render, which ends up going into your view, where it will pattern match on. So if you want to render index.html, you'll say render con index.html, and then that will go to your view, at which point you don't need con anymore, you just need the assigns. So when you call a function in your view, the first argument will be the string that you want to render, so it could be index.html, and then the second argument will be this plug.con.assigns map, and in there you'll have anything that you've set up in your controller. So maybe you've set like the change set, for example, if you're using a registration form, and then that would be available on your template. So if you call form4 in your EEX templates for Phoenix, you can use the @ symbol as a shortcut to conduct assigns. So you could say form4 at change set do, and then in there you may have your text inputs and so on. And then you specify the action that you want to submit the form to. And then at that point, it would send it to the client, and then the logger would finish its timer, and then it would log the output to the console or file or whatever your logger is configured to be. But by default, it's the console.
There's one bit of terminology in there that I don't think we explicitly defined. That's the action. What was the action?
And there's nothing special about the action. It's just a function in a module. In fact, it's not actually called the action anywhere. It's just called the function.
Okay. So what does it do? You said that you pass the template to the action, and then what happens there? That's just where the map gets assigned and plugged into the various parameter slots for the template, or something else?
So your controller function is typically a bridge between your context and your view. So let's go with the register user analogy from earlier. In your create function, you would say case accounts.registerUser or case myapp.accounts.registerUser, and then you'd pass it the params, which was the second argument to the controller, and then you'd probably pattern match on the results. You'd say if it's okay user, then we'll want to redirect with a flash message that says user successfully created. And if it's an error, then typically it'll be error change set you match on, where the change set is an ecto change set. And then you can re-render the same form. And this time, when form4 has the change set, it won't be valid, and you can display like errors for your form fields inside next to the field. So for example, if the username is already taken, then you would have validated that in your ecto change set. It's called a uniqueness constraint in ecto, and it actually checks against the database. And then that will come back with an error saying has already been taken. And then when you render your form field, it'll say has already been taken under there.
Okay, so this is where essentially the business logic of your application happens, and you define what happens in different cases. If you've been able to successfully register a user, you do one thing. Otherwise, you do something else.
Yeah, so typically your context will have all your business logic, and then your controller will just be quite a lightweight function that will just match on the result of that. So maybe you've got like a user limit there, for example. Like if you've tried to register a user and maybe there's already 10 users, then you may have a function you may like just check before you try and go to the database the user limit, and then you may return error user limit exceeded, and you can then match on that. So you might have the atom user limit exceeded, where you want to show a different error message because it's not a change set error, it's just a separate error related to how many users you have. And one of the things you can also do in Phoenix is set an action fallback for your controller, and that's where the term action is used. And that is a function that if any of your actions like index or create don't return this construct that's required, then the function defined in your action fallback will be called. So one way you can handle this is using with in Elixir. The way with works is you match on the result, and if the result doesn't have that shape, then it returns whatever it did have. So you could say, for example, with OK user redirect with the flash message, and then return your con. And if a con's not returned, then the function you define your action fallback will be called. That can match on the errors then. So you can have all your errors in one place. You don't have to actually define them in your action functions.
In episode 336, we talked a lot about pattern matching, but we didn't specifically talk about the with expression. But this is something I have seen a lot in Elixir code and specifically Phoenix code. So I think I'll refer listeners back to episode 336 if they want to know more about pattern matching. But let me just make sure that's clear what you're talking about. You're saying that you can define in this with expression a list of preconditions. So the with and then the pattern is in a way a precondition. If the result of the function on the right-hand side of that expression doesn't match that pattern, the next step isn't going to happen, and you'll go back to a fallback or a default. Is that a fair description?
Yeah, so you can have multiple clauses. So you can say with OK user exists, and then or with OK user, and then look up your user, and then OK permission, and then check the permissions, do, and then that would be your positive happy path for whatever you want to do in this case. And if you don't specify an else, then it will just return the value that didn't match, the first value didn't match. So if the user didn't exist, it would return error not found. And if the permission function returns something else, it might return error not permitted, in which case that would be what's returned. But if you do define an else, you can actually pattern match on the results. You might want to say, okay, I want to do something special in the case of error not found, but for everything else, I just want to return whatever the value was that didn't execute or that didn't match the pattern I was expecting.
Okay, I think that's a lot more clear. And it may sound complicated to people that aren't familiar with Elixir, but my impression was that this is a really compact and expressive syntax that makes things really convenient to write. Was that your impression too, or did it take some getting used to?
Yeah, the feature it's a fairly new feature as well. It came in Phoenix 1.3, which is the latest version, and it's just the with construct came I think in Elixir 1.3. So the with construct's been there for a while, and I've been using it in my code. There's a little bit of a change to use it in a Phoenix controller, but I think it makes sense. Like you can have common errors that are returned in several places, and instead of matching each time, you could just call your action fallback. One thing I did want to mention in a Phoenix controller is that you can conditionally, when you say plug something, you can also say when at the end, so it only applies to certain actions.
I think we covered all of the major components of Phoenix other than the real-time component. And you had a really interesting talk that I mentioned in the introduction called The Road to 2 Million WebSocket Connections. So I'd like to dive into that example to illustrate how the real-time component works, and then also how you would, or how you did, troubleshoot some of the issues until you got to that 2 million connections number.
I was tasked actually at my company to benchmark some of the real-time capabilities of Phoenix, and I used a library called Sung to do some initial benchmarks. The Hello World of Phoenix is a chat application because it's relatable and it's quite easy to write. Default chat application is the one that I used to benchmark, and I didn't get amazing results. I think I maybe got a few thousand connections when I tested it locally, and I was in IRC at the time, and I mentioned this, and no one had really done any extensive benchmarking on it. One of the things in Phoenix is to make it like work, like make the APIs as you want them, and then performance we can kind of tackle as we get to it. And we have some confidence that because we're using Erlang, we should be able to get the performance numbers we want. So I mentioned to Chris I was doing some benchmarking, and he got in touch, and we got some servers provided from Rackspace to do some benchmarking on. And we just fired up the benchmarking code I'd written using Sung. You specify an XML file and the type of test you're doing. So we were doing WebSocket testing, and I think we got something like 30K concurrent connections on the first run.
So the first time you tested this chat application, there's an example application that's a chat application that's kind of a hello world demonstration of Phoenix's real-time capabilities. But the first time you tested it, you got a fairly mediocre result of something like 30,000 connections. And then what happened?
So we got a mediocre result, but on the plus side, no one else had reported that the 30,000 connections was a problem for them. So at least we were ahead of the people using Phoenix. And I think Jose actually came in with the first fix. It was to do with the way that the messages were distributed internally, and it was a small change. In fact, I think it was actually just a net deletion of code. I'm not even sure if anything was added, which is quite impressive. And when we ran the tests, or the benchmarks again with this change, I think we got to 50K connections. So it was good. I mean, it was like what 2/3, a 60% improvement, but it still wasn't where. Like for reference, WhatsApp had a blog post that they had 2 million concurrent connections on one machine, so we weren't We didn't think we were done at 50K.
So for some context, you had this WhatsApp number of 2 million connections, and they're using a pure Erlang system. So they're not using Elixir, and they're not using the Phoenix framework, but you know that just the platform itself could support up to 2 million connections on a single machine.
Yeah, the machine we're using was, I think, slightly more powerful, and we knew that they'd hit this 2 million number. That was largely down, I think, to the Erlang VM. At this point, we hadn't done any like massive tuning. It was just this one change. We did what you're supposed to do. So this is where the long term maintainability comes in, because Erlang has some really nice debugging tools. It has DBG, which is for tracing, which we didn't use in this instance, but it's really good. You can see like when a function's called and how frequently functions are called, and you can do that in production as long as you're careful about what you match on. If you do too much, then it might blow up your VM. But there are libraries to help you with that. But the other tool it ships with that's really useful is called Observer, and this gives you a visual overview of your application at runtime. What we did was we ran the benchmarks again, but this time we opened up Observer. And one of the things Observer lets you see is the message queue size. So I think you discussed it in your Elixir episode, but the way message passing works, or the way you interact with processes in Erlang, is you send messages to each other. And in Observer, you can sort by message box size. And what we observed is one of the processes, the message queue just kept growing and growing and growing and was never going down. So it was clear from that point that there was a bottleneck in this one process that was the timer process. And what we went on to find was that the way we were handling pings to ensure that the WebSocket stayed alive was using an Erlang function timer.send interval, which wasn't the most performant way of doing that, and it caused a bottleneck. So there's another way of doing that called process.send after. We used that and it was better. And then we realized that Cowboy, the web server we're using, does it anyway. So we actually just deleted the entire pinging code and still had the same functionality. And when we did that, we got quite a significant improvement. I think by the time we finished our benchmarking on that, we'd ended up with some 450,000 concurrent users on one machine. So it still wasn't WhatsApp scale at this point, but it was better.
Your test or your benchmark that you were doing was what? What were you measuring?
So the thing we were measuring in this instance was just the number of simultaneous connections we could run on the machine. So we had the inbound user growth set to, I can't remember the exact numbers, but we had it coming in at a certain amount of users per second, and we didn't have an upper cap on it, so we just ran it until it wouldn't take any more connections, and then we just saw how many it would get from that point.
And when you say the number of connections, this was the real-time connections. So these were channels, right?
Yeah, so these are all Phoenix channels. It's probably worth mentioning that channels are the abstraction around the transport, which is either WebSocket or long polling, that integrates with Phoenix PubSub, which is like a way of sending messages between clients, but also between Erlang nodes. So in this instance, we only had one Erlang node, but we could have had a cluster of Erlang nodes, and Phoenix PubSub would have sent the messages between them all.
What were the client connections then? Were they were simulated connections coming from this Sung testing application, or how did that work?
I mean, they're real connections, but they were idling. So what would happen is they would connect, wait for the connected WebSocket protocol message, and then it would just loop infinitely doing nothing. And if it received a response, then it would parse it, but other than that, it would just ignore everything.
Okay, but these are real live connections, and the crucial thing in this test was that the connection had to be held open.
Yeah, so that was the thing that we wanted to see, was how many open connections we could have at one point. And that's why they were just idling, but yeah, they were definitely real connections. And you could verify that as well on the machine. Like if you type netstat and then the multitude of flags you need to count active connections, then it would return the 450K and eventually 2 million that we got to.
Okay, so at this point you had 450K concurrent connections, and you're able to get to that scale by first identifying your first bottleneck, and that was the thing that you were looking for was a growth in the number of messages in the Erlang mailbox that were backing up. Is that something that you always look for when you're looking for a bottleneck, or are there other indicators?
It's a really good starting point, certainly. You have the other indicators like CPU usage and memory usage, but to identify a process level bottleneck, the message queue size or the number of reductions sometimes, which is like how much computation it's doing, those are good things to check. You can also check your atom table size. So atoms, I'm not sure if I actually mentioned what an atom is, but it's like a string, but it's a constant value. So you could have the atom in Phoenix, for example, we use like the atom index for when you call index. But these aren't garbage collected. So if you accept atoms from user input, then this can like overfill your atoms table, use up all your memory, and then it'll crash the VM. So that's another thing that you can find in Observer. And one other thing that you can see in there is your ETS tables. So another source of bottlenecks I've found before is when your ETS tables grow too large, or not too large, but they grow in a way that means your application slows down, for example, when you're looking them up because they've got too many entries in them.
ETS tables is something we hadn't covered yet. What is ETS and what role does it play?
So ETS is Erlang term storage. It's actually the next optimization that happened in Phoenix when we were benchmarking the channels. It's essentially a key value store for Erlang terms, and you can look them up based on like what key you insert. We use them in Phoenix for storing the topics, so you can look up which users are in a channel or which channels a user has associated. You can look these things up in ETS.
Sometimes you might call it Ets, sometimes you call it ETS, but it stands for Erlang term storage. And you can put any kind of Erlang term in there, I would assume, which would consist of what? Like what's an Erlang term?
Typically, atoms are used for your keys, but an Erlang term is like anything that you can type in Erlang is an Erlang term. So, like if you have a map of strings to other maps, that's a term. Like it's just the Erlang data format.
Okay, so effectively, it sounds like ETS is a distributed database, but it's not necessarily persisted.
It's not actually distributed. It's node local. Amnesia, which is the database built on top of Ets, that's a distributed database, but Ets itself is node local. And there's also DETS, which is disk Erlang term storage, and that allows you to persist your ETS table to the file system.
All right, thanks for that clarification. I remember from your talk that there were a couple different optimizations you made around Ets, and one was, I believe, you needed to use Ets instead of using a different local. I think it was a local hash dict. So you, instead of using just a dictionary, you used Ets, and I'm curious why that was an important optimization. I didn't quite understand. Can you explain?
It just happens that Ets is more efficient to look up than a large map generally. Quite often, if you've got a map of terms that you are storing in a gen server, which is just a process in Erlang, then you'll often find that using an ETS lookup will be more efficient.
And the second optimization had to do with using the wrong type of data structure within Ets. Could you explain that?
Yeah, so Ets has different types of tables. It has sets, ordered sets, bags, and duplicate bags. A bag is just a set of, not a set, that's the wrong word to use. A set is a set, but a bag you can store terms in. But when you store them, if you have a term that's already there, then it will check for duplicates. But in the case we were doing, it didn't really matter if you're going to have duplicates because it was each entry was a unique session. There wasn't a chance for duplicates anyway. So the thing we were getting bottlenecked on was ETS checking for duplicates as it was inserting new sessions. So we changed the type from bag to duplicate bag, and that just it was like it was a different application. Like if you look at the difference in charts and the benchmarks, we could get a much higher rate of users per second, and we eventually got to 2 million connections. And the reason it stopped at 2 million is because the U limit we set on the machine, we set to 2 million as like this figure that we would never hit, and we did. So it could have probably gone further, but that was where we stopped because at that point we had like 65 machines running, and it was getting expensive.
What was it that allowed you to detect that particular problem to get to that optimization?
I think just isolating the benchmarks. So the person who did it was Gabby Zuniga, and he said he isolated that section of the application and benchmarked it on its own, and he discovered the bottleneck there. And I think the general takeaway is just to know your data types. Consider what type you're using up front. So, for example, I think bags may be defaults. That's why it was used. But had we considered are duplicates going to be a problem here or not, then we may have gone with the duplicate bag straight away, and that problem wouldn't have existed.
We'll put links in the show notes to the blog post and also the talk that you gave with a full breakdown and all the charts. Are there any other takeaways from that test that we should talk about before we move on?
I mean, I think that was it. I think just really think about what your data types are and where your bottlenecks are going to be to try and anticipate that when you're building an application. But also, I mean, it's worth mentioning that like performance isn't the most important thing. No one hit the initial bottlenecks that were quite low, and it wasn't until very recently that there were some additional optimizations on Phoenix PubSub where I guess they were maybe getting closer to the upper limits. But when we did have the 2 million connections, the other thing we observed was that sending a message. Jose was trolling us and sent an entire Wikipedia article through the channel because we still had the web clients running, so you could go on and you could see the application running. And he sent like the entire Wikipedia article of, I can't remember what it was, but of like the Erlang programming language, and it was distributed to all the clients in a few seconds. So that was also an unexpected part of the benchmark.
Sounds like you're saying you might want to defer optimization until you know what it is you're trying to optimize. Like you might be sending a lot of small messages, or somebody might just decide to dump an entire Wikipedia article. But Phoenix is able to cope with these cases, but in your specific application, you might need to do testing and do like tuning depending on what type of data you're actually dealing with.
I think that's fair. Yeah, this specific benchmark was very artificial. Like I can't think of many practical use cases where you need a chat room with 2 million people in it, but that was the thing that exposed these bottlenecks, and it was a deliberate test to find concurrent connections because it just shows like the theoretical limit for Phoenix when it comes to how many simultaneous users. But in a more real world use case, you might have like thousands of channels, each with 10 users or each with 20 users.
So we talked about the different parts of Phoenix, and we got into the specific performance tuning example. And one thing that you mentioned was that you're using the Cowboy web server. And it reminded me that beyond Phoenix, there's also other parts of the Elixir and Phoenix ecosystem. So what are those pieces that maybe we haven't talked about that you'd probably want to have in your application, or that you might add as a dependency?
So Cowboy was actually written in Erlang, and we're very grateful for it because otherwise Phoenix would have been delayed by about a year once a web server was developed. So Cowboy is definitely a dependency. In Phoenix 1.4, we're moving to Cowboy 2. Well, optionally moving to Cowboy 2. You can use 1 or 2 and it'll work out which Phoenix adapter or plug adapter to use. And Cowboy 2 comes with some new features, like it supports HTTP2. So you'll get like HTTP2 pipelining. So we really leverage that, and we're grateful for that exists. There are other ecosystems popping up around libraries. So GraphQL is one. GraphQL has its own like little ecosystem with a set of libraries around there. The authors of GraphQL, Absinthe, the GraphQL library for Elixir, Ben Wilson and Bruce Williams, they've got a good book about building applications with Phoenix and GraphQL using their Absinthe library. There's also Nerves, which would probably be a show in its own, which is targets embedded devices, so you can boot into Elixir and maybe run it on a Raspberry Pi. And it's quite common for a device running Nerves to have a Phoenix server running for like the UI, for example, that people may want to use.
We'll include links to those projects in the show notes. I had one more question. Does Phoenix include some facility for scheduled jobs or long-running processes, or is there some library that plugs in that does that?
So Erlang has, because you're running on the Erlang VM and you can have a long-running process, you can just do it in Elixir. So Elixir has a task module which you can use to run tasks asynchronously, and you may have a process that says every minute see if there's any new tasks to run, or every particular time period you want to execute a task, and that's how you do like a scheduled task. But it depends on where you deploy. So if you deploy on servers dedicated servers, I guess, then things like this are fine. But if you're deploying on something like Heroku, then I know they kill and spin up their images, so you'd maybe lose data there. And for those sorts of instances, there are libraries. I haven't used any of them personally because I just tend to use Task and Gen servers to schedule tasks, but there are queuing libraries available that people have developed.
Speaking of deployment, we could go into that a little bit more. What are the various deployment options and what do you recommend?
One of the libraries that someone has developed, his name's Bitwalker on GitHub, has developed is called Distillery, and that allows you to generate a tar file from your Elixir project. So it's not Phoenix specific, but you can generate a tar file. You can upload that tar file to your server, untar it, and then in there you can start your application. You run the mix release task and it'll compile your application and build this tar file for you. It supports hot code upgrades, which is something in the Erlang VM that allows you to have two versions of a module loaded and a transformation function called code change that you transfer from the old format to the new format. Distillery will allow you to do that. When you want to build a release, it's important you also compile your assets, which is where we use Brunch or Webpack, but you'll want to use that command. And then Phoenix comes with a digest command, which will generate a manifest file and version your assets so the caches are invalidated when you do a new deploy. There's also Heroku build packs available for Elixir and Phoenix, and in there you can specify which versions of those you're running, and then you can deploy on Heroku however you would normally do so. There are some Elixir specific deployment services. I've never used them, but I've heard of Gig Elixir and I've heard good things about that. So that might be worth checking out if you're deploying a new Elixir project.
Are there any specific challenges to deployment or operational challenges in terms of monitoring that are Phoenix specific that you know of?
No, there are libraries. A lot of the big libraries have the big services for monitoring have Elixir support, like AppSignal does. Rollbar and New Relic all have Elixir Phoenix support. You also have all the tooling that you get from Erlang, so any Erlang specific monitoring you can apply. So in terms of monitoring, there's not any specific challenges.
Was there anything else we didn't talk about that you wanted to mention?
There's a couple of things coming out that are exciting in the ecosystem. There's a library called Telemetry, which will be for metrics that's being worked on, and there'll be Phoenix integration for that probably at some point. And in terms of Phoenix, there's a project called FireNest, which is extracting a lot of the lessons we learned in PubSub which, as I mentioned, is for sending messages between nodes in an Erlang cluster. So Firenest will be hopefully a good way to build distributed applications when it's done. The other new feature that's coming after Phoenix 1.4 is Live View, and Chris McCord does a good demo of this and a good introduction to it in his ElixirConf keynote from ElixirConf US. But the gist is that Phoenix is a way for building real-time applications and real-time view rendering without having to write JavaScript. So you can, let's say you've got, a background task running and you've got a progress bar. You can write Elixir that will render a small amount of HTML that will be sent over the Phoenix channels, and that will re-render a portion of the page with a progress bar on it, for example.
I see. So it's doing live updates to HTML without any JavaScript.
I mean, it has JavaScript, but without you writing the JavaScript. And that's not to say that we're saying no one should ever write JavaScript ever. It's just a way to add bits of like real-time functionality without the overhead of, for example, bringing in a JavaScript framework.
Okay, so we'll include links for telemetry, Firenest, and Live View in the show notes.
There won't be a link for Live View, but you can link to the keynote which introduces it.
Got it. Okay, will do. All right, Gary, it's great having you on the show. How can listeners find out more about you or follow what you're doing?
I'm Gazler pretty much everywhere on the internet except for Twitter, where I was late, and I'm the Gazler. I'm most active on those, and IRC as well. Thanks
again, Gary. It's been really great having you on Software Engineering Radio.
Yeah, thanks for having me.
This has been Nate Black. Thanks for listening.
Digitalocean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.